up to this point, we have talked about both exponential expressions and logarithmic expressions. Now we're going to shift focus and we're actually going to have exponential or logarithmic equations that we can solve. When we're solving an exponential equation, the method that we use to solve it will really depend on the way the equation looks. So if you have, for instance, an equation that looks like this, notice I have just one exponent and the other side is a constant. However, this 81 is a number that is a base 3 number, meaning I can rewrite 81 as 3 to the 4th, since 3 times 3 is 9, times 3 is 27, times 3 is 81. Now, if I can write it that way, and notice this is my new equation, 3 to the x minus 7 equals 3 to the 4th, what I can do is drop the base, which means essentially what I'm doing is taking log base 3 of both sides, and the log base 3 of 3 cancels out, and that leaves me with x minus 7 equals 4. Now, do I need to show that step? No, I don't. I can just drop the base and set the exponents equal to each other. X minus 7 equals 4, add 7 to each side to get x equals 11. So here are two like that for you to try on your own. 1 over 8, again, 8 is a base 2 number, not a base 4 number, but base 2. So 1/8 can be rewritten as 2 to the negative 3. Again, the negative is what flipped it to make it a denominator, and then of course 8 is 2 to the 3rd. On the right side, this is 2 squared. 4 is the same as 2 squared, and then x. So essentially what I have is 2 to the negative 3 equals 2 to the 2x. Now I can drop the base and end up with negative 3 equals 2x, divide by 2 to get x equals negative 3/2. Over here, same idea, I have 8 and 4. 8 is the same as 2 cubed, and 4 is the same as 2 squared. Notice what I'm doing is I'm writing the existing exponent in parentheses to remind myself that when I do drop the base, I do have to end up multiplying the new value by the other values that were there. So when I drop the base, I get 3 times x plus 3, and I get 2 times 5 minus 2x. Of course, I'll distribute the 3 to get 3x plus 9, and the 2 to get 10 minus 4x. I'll subtract 3x. Nope, I'll add 4x to each side. That gives me 7x plus 9 equals 10. I'll subtract 9 from each side to get 7x equals 1. And then I'll divide by 7 to get x equals 1/7. And that's my final answer. The next type of question that we will do is when you cannot rewrite it with the same base. So notice 7 is not 2 to the anything power. So therefore I cannot use the method that I just learned. Now I'm going to isolate the exponential expression, which I've already done, and then I'm going to take the logarithm of each side to simplify. Two ways to do that, using log base whatever I have here, which I prefer, or using the common log, which is likely the way Alex will explain it to you. If I take log base 2 of 2 to the x equals log base 2 of 7, log base 2 of 2 cancels out, and I just get x equals log base 2 of 7. Now, if they want me to write it as a logarithm, I'm done. Most of the time, they will, of course, want me to, say, round it to the nearest 10,000th or something. Well, this is where we'd have to use that change of base formula in our calculator to put log base 10 of 7 over log base 10 of 2 and find that value in our calculators. And if they did ask me to round, I would get a value of 2.8074. Using the common log, it would sort of prevent me from having to do this step at the end. I would have log base 10 of 2 to the x equals log base 10 of 7. Again, the x would move out front. I would still have this log on the left side because it wouldn't go away like it did on the last question. I would then divide each side by log of 2, so I would get x equals log of 7 divided by log of 2. And then, of course, I would do the exact same thing I did here. and find that decimal, which would be 2.8074. Again, not rounding the intermediate steps, but using those full values in my calculator. Here are 2 questions for you to try, so try them both, then press play to check your work. Again, the first question, I would look at writing this as log base 2, possibly. Log base 2 of 2 squared times 0.03x equals log base 2 of 0.2. This side, the log base 2 of 2 would go away, and I would have 2 times 0.03x, which is 0.06x. And on this side, I would have log base 2 of 0.2. Then I would divide each side by 0.06. And then I would, in my calculator, find, again, I would break this into log of 0.02 divided by log of 2, and then divide that by 0.06. My final answer, if they asked me to write it in a decimal equivalent form, would be negative 38.6988. If they were really looking for an exact answer, I probably would have left it as this divided by 0.06. I would have left it like this, or written it like this and then shown that it would be then divided by 0.06. So pay attention to what they're asking for in the question. Same thing's going to happen here. I have log, and for this time let's just do log base 10. So log base 10 of 3 to the x equals log base 10 of 51. That gives me x times log of 3 equals log of 51. I would then divide each side, so x is log of 51 divided by log of 3. And then of course that would be an exact answer. I would then find the decimal equivalent using my calculator, and I would get 3.5789, or 3 and 5,789 10,000ths. If you have an exponential equation that contains e, the process is the same, but instead of taking the log of each side, you would take the natural log of each side. Again, the first thing I would do though is try to get this by itself. So I'm going to start by subtracting 4 from each side, which gives me 2e to the 3x equals 8 by subtracting 4. And then I would divide each side by 2 to get e to the 3x equals 4. From here, I would finally then take the natural log of each side. So I'm going to take the natural log of e to the 3x equals the natural log of 4. The natural log and e, that stuff cancels. I get 3x equals the natural log of 4. So my exact answer is the natural log of 4 divided by 3, and then I could use my calculator to find a decimal equivalent depending on how they want the solution. The decimal equivalent would be 4,621 10,000ths, rounded to the nearest 10,000th. Here are 2 of those for you to try on your own, so try them both and press play to check your work. For the first one, I would start by dividing each side by 700, which would of course give me 1/7 on the left if I reduced, equals e to the negative 0.2k. I would then take the natural log of each side, so the natural log of 1/7 equals natural log of e to the negative 0.2k. This side, that stuff would cancel and just give me negative 0.2k. This side I'm going to leave it as natural log. I would then divide by negative 0.2. And then I would use my calculator to find that decimal equivalent. My decimal equivalent would be 9.7296 equals k. Again, to find that exact answer, I leave the full answer of natural log of 1/7 in my calculator before I divide it by the negative 0.2. For the next one, this one's a little bit easier. I'm just going to go straight to taking the natural log of each side. On this side, that just gives me x. So x is the natural log of 14.7. And then I'm just going to use my calculator then to find a decimal equivalent of that. And that would be about 2.6878. I want to do this last one with you because it's sort of involved. It's kind of complicated. So let's take a look. Notice the base is different. and I really couldn't solve this by taking log base 2 or log base 3, and so I'm just going to use the common log, and I'm going to do that to both sides. So if I take the log of the left side and the log base 10 of the right side, what I end up with is all of this exponent now being a constant. So I have 3x minus 2 multiplied by log of 2, and I have 2x plus 1 multiplied by log of 3. And right now this is sort of ugly, but it's going to get worse before it gets better, because like we have done before, I really want to get all of my values that have an x to one side. But in order to do that, I'm going to have to multiply, I'm going to have to distribute this log base 2. So I have 3x log of 2 minus 2 log of 2 equals 2x log of 3 plus log of 3. So now I can see that I've got this 3x log of 2 and this 2x log of 3. So I can move, I'm going to subtract 2x log of 3 from each side. So that gives me 3x log of 2 minus 2x log of 3. And for the sake of space on the same step, I'm going to add this 2 log of 2 to the other side. So I have 2 log of 2 plus log of 3. So now I've successfully gathered my x values to one side. Again, just as I did before, I'm going to take that x out of it. So I have 3 log of 2 minus 2 log of 3. And on the right side, I haven't done anything. Now, in terms of whether or not you want to turn that into log of 4 instead of 2 times log of 2, you may do that. And of course, this would be log of 3. It doesn't matter because you're going to get the same answer either way. So I'm going to divide both sides by this entire expression. And of course, on the left, that means it will cancel. On the right, I have my exact answer. And then, of course, I can use my calculator to find the decimal equivalent. Again, if you feel better about it, turn this into log of 4, 2 squared, which would be 4, plus log of 3, and then log of 2 cubed, which would be log of 8, minus log of 9. Or do it exactly this way, but go ahead and use your calculator to evaluate the end of that one. Using my calculator, I find about negative 21.0973. Again, do that so that you don't have to do any intermediate rounding so that you can find the most exact answer possible.